So we're going to be finding the probability of compound events. In an earlier video, we found the probability of simple events. So a simple event was a single event, or when one thing happened. Compound event is just going to be when you have multiple things going on. How do you find the probability of more than one thing? Okay. So before we look at that, we're going to look at an example. Jamie is shopping for a new car. The car she likes can be purchased in blue, silver, red, or purple. It comes as a convertible or hardtop, and she needs to choose between leather and cloth seats. Right? Complete the list of all the possible options below, then find the probability that Jamie will randomly choose a red convertible with leather seats. All right, so this is our list of sample space. Remember, sample space is all the items that could happen. All right, so I can see that she's done the blue with both the convertible and hardtop and with either type of seat. Okay, and then she started red, so it could be a red convertible with leather, or it could be a red convertible with cloth. All right, or it could be a red hardtop with leather, or it could be a red hardtop with cloth. Okay, and then I can see it's silver, convertible, leather cloth, silver hardtop, leather cloth, so those are all good. Okay, or it could be purple, the last color, convertible, leather cloth, right? Or there's still more purple, right? Purple, but instead of convertible, it could be a hardtop. Okay, so there's two of those, right? Purple and hardtop. And then you're either going to have leather seats or you're going to have cloth seats. All right, so if I want to know the probability of all of these things, it's red, it's a convertible, and it's leather, then how many times did I get red, convertible, leather? Well, I got it once right here. Okay, I got it one time. Out of how many total? That's how you find the probability. So if I count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, out of 16. 1 out of 16. All right, in order for this to happen, okay, for that to happen, 3 different things had to be true. Okay, it had to have the right color. Okay, the car had to be a red car. So what's the probability of getting red? Well, if I just look at red and nothing else, how many colors were there? 1, the blue, right? The red, the silver, or the purple. The probability of red would be 1 out of 4. Okay. The probability of a convertible, well, it was either a convertible or a hardtop. All right, the convertible or hardtop, it had to be either this or this. So that would just be 1 out of 2. If I want to know the right types of seat, for the probability of a red convertible leather, it had to have leather seats, right? But what's the probability of just leather? Well, there were only 2 options for the seats, right? It was leather and there was cloth. Okay, so the probability of leather is just really 1 out of 2. Well, if you notice what happens, if I take the 1/4 and the 1/2 and the 1/2 and I multiply them all together, okay, then on top, 1 times 1 times 1 is just 1. On bottom was 4 times 2, 8. What's 8 times 2? 16. Notice that what I get is what I got here just from my list of sample spaces. All right, and this is going to be something that's true for compound events. All right, I can make the sample space and find the probability. But then this little trick here, okay, where you multiply the individual probabilities together will give you the probability of the compound event as well. Okay, so let's practice that. When only one event happens, or only one event, not events, happens, okay, and that's called a simple event. We did this earlier. Right? That's like flipping a coin, rolling a dice one time. All right? When more than one event happens, then this is called a compound event. Okay, so it could be more than one event happening, or it could be an event repeating too. Okay, that's also called a compound event. So that would be like flipping a coin and rolling a number cube. Or it might be flipping the coin 2 times. All right, that would be an example of a compound event. The probability of compound events can be found by using the sample space. Okay, that's what we did on front when we completed the list. Or you can multiply the probabilities of all the events together. All right, so I'm going to show you, we're going to do it both ways. You can choose how you like to do it. Okay, suppose you toss a quarter, a dime, and a nickel. All right, determine the sample space. What's the probability of getting 3 tails? Check your answer by multiplying. All right, so if I want to find the probability with the sample space, I can use a list or I can use a tree diagram. I like the tree diagram, so I'm going to use that. So for the quarter, I can start with, I'm either going to have heads or I'm going to have tails. Okay, so this is my quarter. Okay, then I'm going to toss my dime. All right, so my dime, I'm either going to have a quarter, I'm either going to have heads and then heads again, or I'm going to have heads and then tails. Okay, or if I start it with tails, I'm either going to have heads or I'm going to get tails. Okay, but then I have to toss the nickel. Okay, so then that means I'm either going to have heads, heads, and then heads again, or heads, heads, and then tails. Okay, or I can have head, tails, and then heads, or head, tails, and then tails. Okay, or down here I could start with tails and get heads and then heads, or tails, heads, and then tails. Okay, tails, tails, or heads, tails, tails, or tails. Okay, so if I just make a list based on my tree diagram, then if I read the branches, right, I could have a head, and then another head. Okay, or I could have heads, heads, and then tails. Okay, or here I could have heads, tails, and then heads. Follow the branches. Heads, tails, and then tails. Okay, I could have tails, heads, and heads. Okay, or if I could have tails, heads, tails. And then the last branch, set of branches, I could have tails, tails, heads, or tails, tails, tails. All right. What's the probability of getting 3 tails? Well, there's only one out of how many? 1, 2, 3, 4, 5, 6, 7, 8. Remember, you count the end of your branches to know how many how many outcomes there are. So there was 1 out of 8. That's your probability of getting tails. Probability of 3 tails. 1 out of 8. Okay, then it says, all right, check your answer by multiplying. So the way I do that is I find the probability of tails times the probability of tails times the probability of tails. All right, what's the probability of just getting tails for a quarter? 1 out of 2. What's the probability of getting tails for a dime? 1 out of 2. What's the probability of getting tails for a nickel? 1 out of 2. And by the way, what are we using? Experimental or theoretical? Well, we're back to theoretical, right? We're just saying in a perfect world, this is what should happen. All right, so if I go ahead and multiply these all together, 1 times 1 times 1 is 1. 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. All right, so did we get the same thing? Yes, we did. All right, look at the second example. The animal shelter has both male and female Labrador retrievers in yellow, brown, or black. There's an equal number of each kind. What's the probability of choosing a female yellow Labrador retriever? All right, so we have 2 kinds of dogs. We have male and we have female. I'm going to do my tree diagram going a different direction. All right, and then the colors are also something that could change. They're all labs. So I can have a male yellow, a male brown, or a male black. Okay, female, I could have yellow, I could have brown, or I could have black. All right, I want to know the probability of choosing a female yellow. A female yellow. Okay, so that would be this one right here, female yellow. That's 1 out of how many total? 1, 2, 3, 4, 5, 6 out of 6. If I want to check my answer by multiplying, then I do the probability of each one. So the probability of getting a female, okay, was, times the probability of getting a yellow lab. So the probability of getting a female is 1 out of 2. The probability of getting yellow is 1 out of 1, 2, 3 out of 3. So if I multiply these together, 1 times 1 is 1, 2 times 3 is 6. These should be the same, and they are. So 1 and 6 is my answer. All right, look at 3. flip a coin one time, then roll a number cube, right? What's the probability of getting tails on the coin and rolling a 5 on the cube, right? Again, if I make a sample space, I can start with flipping. I have my coin. What's going to happen when you flip a coin? You're either going to get heads or you're going to get tails. Then you're going to roll the cube, and what's going to happen? You're either going to get a 1, I have a bunch of branches, a 1, a 2, a 3, a 4, a 5, or 6. Okay, or I'm going to start with tails, and I'm going to get a 1, a 2, a 3, a 4, a 5, or a 6. All right, so remember the end of my branches is how many things could happen. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibilities. I wanted the probability of getting tails on the coin and then rolling a 5. Okay, so getting tails and rolling a 5. That's this one down here. So how many times did that happen? Once. Out of how many total? Well, we already counted them. There were 12. Okay, or if you want to do it multiplying, find the probability of getting tails and then multiply that times the probability of getting a 5. Okay, so if I just flip a coin, the probability of getting tails is 1 out of 2. The probability of getting a 5, okay, if I just roll a cube, is 1 out of 6. If I multiply 1 times 1, I get 1. 2 times 6 is 12. So again, these are the same, 1 out of 12. All right, look at the last one. You roll a number cube twice. Find the probability of 3 and then 1. All right, so this time I'm going to skip the sample space and just use multiplying. So when I roll a number cube, all right, the probability of rolling a 3, and then I want to multiply that times the probability of getting a 1. So in a number cube, right, what's the probability of getting a 3? Just 1 out of 6, because there are 6 sides. Probability of getting 1 out of 6. So if I multiply those together, I get what? 1 out of 36. All right, and the next one, the probability of even and then greater than 4. All right, so I want to know the probability of even and then multiply that times the probability of greater than 4. I'm going to abbreviate. All right, so on a number cube, it could be 1, 2, 3, 4, 5, 6. How many of them are even? The 2, the 4, and the 6. So 3 out of 6. Probability of greater than 4. Okay, so how many of them are greater than 4? So that would be the 5 and the 6. So that's 2 out of 6. If I multiply those together, 3 times 2 is 6. 6 times 6 is 36. Okay, that can be simplified. So I have to divide by 6, which gives me 1 out of 6. All right, so this is the probability of compound events. Compound events are when you have more than one thing happens or you have something repeatedly happening. Okay, again, you can make a sample space, a list, or a tree diagram, and then just find the probability based on that, how many times it happened compared to how many different possibilities there were. Or you can multiply. Just find the probability of each individual thing happening and then multiplying it together.